Dear student, good afternoon. Sajjad Hussain again. This is my second lecture in physics. In my previous lecture, I was discussing vectors and equilibrium. And so far, what I have discussed, let me show you what I have discussed so far. As per the list, we have discussed the definition of scalars and vectors. We also discussed vector representation, coordinate system, Cartesian coordinate system. We also discussed sum of vectors by head and tail rule, then multiplication of vector by a scalar quantity. Then also we discussed resolution of vector into two components. These are called rectangular components. And finally we discussed the addition of vectors by rectangular component method. Now we are going to discuss scalar product, vector product, conditions of equilibrium, and we will try to solve some numerical problems. So let's start our discussion. We will start with vector products. So we will discuss product of two vectors. Product of vectors. We will consider two vectors and we will see what happens if we multiply two vectors. So for example, let us suppose that there are two vectors A and B. So if we multiply A and B, what will be the result? Possible results are either the resultant will be a vector quantity or it may be a scalar quantity. It depends on the situation. For example, we know that when a force is multiplied by displacement, the resultant is work, and work is a scalar quantity. But when a force is multiplied by its lever arm, then the result is torque, and torque is a vector quantity. So these two are very classical examples. So let us start with the scalar quantity, scalar product first. So a scalar product means when two or more, we are not discussing more vectors now for the time being, so that's why I put it in parenthesis. When two vectors are multiplied and the result or resultant is a scalar. So in that case, this product is called a scalar quantity. As I give you the example, work is a classical example where force and displacement, these two vectors are multiplied. This scalar product is represented by a dot like A dot B. So this is equals to C, which is a scalar quantity. Sometimes this is also referred to as dot product. And when two vectors are multiplied resulting in a vector quantity, that is called a vector product. So let us define the vector product. That means when vector A is multiplied by vector B and resultant is a vector C. I missed one thing. Here A dot B this result is a scalar quantity. This is equals to A B cos of theta, where theta is angle between A and B. Theta is between A and B. Now vector product, when two vectors are multiplied and the resultant is a vector quantity, the C is a vector quantity, that's why I put a bar on it. So this product is called a vector product, and this is represented by a cross, that's why this is called also called a cross product. That means this resultant C, it will have magnitude and dimension both. So the magnitude is given by this formula: A cross B is equals to A into B into sine theta, where of course theta is between A and B. And now what about the direction? So let us try to understand direction. Not a good representation. So now we can say that this side is x, this is our x-axis, or let us follow the right hand rule, that will be easy for us. So suppose this is x, this is y, and this is z. Angle between x and y, of course, this is 90 degree. Angle between y and z is also 90 degree, and of course x and z also 90 degree. So this is a three-dimensional coordinate system. In that case, what will happen? Suppose we have two vectors. Sorry. A vector A is acting in x direction, and vector B sorry. So this vector A and this is vector B. A is acting along x-axis, B is acting along y-axis. So if A is multiplied by B, resultant will be a vector quantity C, and that will be, of course, acting in positive z direction. So this will be our resultant vector C. This will follow our right hand rule system. What does it mean? Here we can see that the vector A is acting in x direction, so we can put our fingers along x-axis, and if we move our fingers from A to B, that means if we move or we try to close our fingers in right hand side from A to B, then our thumb will be indicating upward, and this thumb will be acting in upward direction, so our resultant C will be acting in upward direction. So these are three perpendicular vectors A, B and C. So if we apply this formula over here, let us see what is the result. So in that case, vector A cross vector B, this is equals to magnitude of A into magnitude of B into sine theta. Here theta is 90 degrees. So we know that it will be equals to A into B into sine 90 is 1. So this will be equals to A into B. So this A into B, that is the product, this is the magnitude, this will be the magnitude of vector C. And direction will be determined as per the right hand rule as shown in this picture. That if A and B, they are mutually perpendicular, they are in a plane, then C will be perpendicular to the plane following the right hand rule system. So this is our vector product system. Now let us discuss equilibrium. What is the meaning of equilibrium? Let us take an example. Say there is a body of mass m. It is resting on a table. So we can say that there are two forces acting on it. One, its weight is acting downward, which is nothing but mg, and then reaction of the table is acting upward, and we know that this reaction will be equal to W, which will be equal to mg. So this body is at rest, and we can see that if we sum these forces, if according to Cartesian coordinate system, this is x, this is y, all the upward forces are positive, all the downward forces are negative, so we can say if we sum the forces, so the result will be plus r minus w. Since both of these vectors are equal, so the result will be 0. Now, in the same example, if we apply a force, say F, which is equals to say 10 Newton in right hand side direction, so this body will start moving in right hand side direction. Yeah, that means this body will start moving in positive x-axis direction. But if we want to stop it, what we have to do? We have to apply same force but in opposite direction. That means we have to apply a negative force or negative 10 Newton force. Under these conditions, this body will be in static position. So in that case, again, if we sum the forces, this is in y direction, if we sum the forces in x direction, so positive F and negative F, it will be 0. So this is a condition of equilibrium, that this is our first condition of equilibrium. The summation of all the forces acting on a body should be equal to 0. That means all the forces which are acting in positive x direction should be equal to the forces acting in negative x direction. The forces which are acting in vertical direction upward should be balanced by the downward forces. So in that case, this body will remain stationary and we will say that this is in equilibrium. But now the question is it the sufficient condition for equilibrium or we need something more? Let's example another case. Let us draw a body and two forces are acting on it. One force is applied over here and another force is applied over here. Now, will this body be in equilibrium or will this body be static in equilibrium? The answer is no. So what will happen? This will start rotating in clockwise direction. Now the first condition is balanced. We can see that the sigma f x is equals to 0 because the force which is acting in plus direction and the force which is acting in minus direction, they are equal, opposite, they are cancelling each other. But this is not in static equilibrium condition. This body will start rotation. Why? Because these two forces are not passing through the same point, rather they are at a distance, say for example d. So they will produce a torque or couple or torque. So this will be equals to the force multiplied by displacement or the lever arm. Sometimes it is called lever arm. So it will be force multiplied by the lever arm. So this will give a torque and this torque will be equal to F cross D, and then this torque can be calculated as f d sine theta. Now if we want to stop it, what we have to do? If we want to stop it, we have to apply a same torque in opposite direction. That means to get equilibrium, all the torques should be, sum of all the torques should be equal to 0. So this is our condition number 2. We can say all the torque or all the moment should be equal to 0. That means this is called static equilibrium. That means when the body is at rest. So when the body is at rest, we know that it is satisfying two basic conditions, and these conditions are called conditions of static equilibrium. The first condition is sigma f should be equals to 0, and the second condition is sum of all the torque or moment should be equals to 0. When both the conditions are satisfied, only then we can say that this body is in a static equilibrium. These concepts are very, very helpful in solving the problems. Now what I will do, I'll stop my lecture over here today, and in my next lecture we will try to solve some problems in equilibrium or static equilibrium or statics. So for the time being, let us stop over here. Please do not forget to subscribe my channel. Thanks. Bye.